Hello again. We're going to go through gravity in orbit Phet simulation. So let's look at that. I'm just going to go through it. It's not calculation heavy. It is observing how gravity affects the motion of planets and satellites. So you're here, you're going to fill this out to the best of your ability, and it might take 2 days. Like it might take we might get through half today and half next time, which is fine. You're going to click on this simulation here, and you're going to push play. And I would use the model. The scale, to scale means it's like actual sizes, like comparable. And so like you won't be able to see a lot of stuff. So the model works, but you can play with the scale too. Let's look at the model. Okay, so here we have the Earth and the Sun, and you push play, and you can see the orbit. It's counting the days. You could zoom in. I like putting force vectors. Like there's the force of gravity. That's what we calculated earlier today on our universal gravitation practice. His velocity, there you go. Look how fast he's going, pretty fast. Velocity vector. Here's tracing a nice path. And you put a grid on. So every rotation around the sun is, 1 year, 365 days. Yes. So what else can we do? Okay, so now, we've seen you could change the distance between things, and you can see how that affects. Let's see if we can grab this. Let's see, we can grab the Earth. What if it was further away? What would happen then? I don't think we're gonna make it. So see, if we were just like a little bit further away from the sun, then our orbit wouldn't work. See, we'd just go off forever. What if we were too close to the sun? No. So yeah. So if we're too far away, we'll, just we'll reach the escape velocity, right? And we'll get away from the sun, and we'll just keep on going until we hit something else. We'll run into a black hole or something, or we just go on forever. Who knows? If we get too close to the sun, gravity will pull us in, and we'll crash, right? Let's reset. Reset. See it again. You can also change things like the mass. What if the sun? What if we're the exact spot where we're supposed to be? What if the mass of the sun increased? What happens? What is happening? Boom. Oh look, maybe that. So if the sun got bigger, maybe we'll be safe. Interesting. See, the Earth is just big enough to keep on orbiting. What if I make the mass of the Earth less? Oh, nothing. Well, that's it. All right, so play with that. Now look at this moon one is very interesting. Look at this. Look at this nice path. So the moon is going around the Earth. Look at that. What a nice design that makes. See, it's weird how it spins around the Earth and it makes this nice. Now, this is how, rotation of things. Sometimes celestial objects look like they're going in reverse, and it's because of the rotation. And I don't know. I'm not an expert at astronomy, so you could also look at this is just like a GPS satellite. Boom. All right. So you just got to play with this and answer the questions. Uh, so you start off the pre-lab. So you're actually supposed to do the pre-lab before. In the picture, draw how you think the Earth moves. So let's look at that. I'm going to make my copy to delete here. So on the ones where it asks you to draw on it, you could use the insert drawing function. And let's see. So you can actually copy this picture and say insert drawing. So I pushed control copy on the picture I wanted to draw on, and I just put it in here. I paste it, control V. And then I can draw on it. So let's say this was in the picture below. Draw how you think the Earth moves. I think the Earth moves like this. Ooh. Is that true? No, but that's what I'm going to put. So there you go. So you can erase the old one. See. Then draw a picture using arrows to show what you think the forces might be on the Earth and the Sun. You can draw a longer arrow to represent a big force and a shorter arrow to represent a small force. 1 second. So here I might draw insert drawing. How do the forces look on the sun and the so you go here to scribble. So here's my sun, here's the Earth. So what do the forces look like? Oh, this force, maybe there's just one big one. I don't know. Is that what it looks like? Is that what we've been talking about in gravitation? Um, check the notes to put that in. But that's my guess. There you go. Draw a picture how you think the Earth would move if the forces were not there. Okay, so this is an interesting one. So this one, draw a picture of how you think the Earth would move if the forces were not there. Well, let's take a look at that. So let's put the Earth and Sun. Let's reset it. Let's put on the forces. Okay. All right, so everything's moving along. This is us now. Now, what would happen if we just turned gravity off? There was the forces of gravity go to 0. Let's see what happens. Let's see. So I'm going to turn them off now. You just click this button. What is happening? So you guys can draw that, maybe write a sentence about it. So that'll go in there. I think blah, blah, blah. And then what happened? So again, you could copy that, insert drawing. I wonder if you can edit that. No. So you have to insert a new drawing. Insert drawing. And then draw what you think is going to happen. Okay. Next, draw motion of planets, moon and satellites, draw diagrams to show how gravity is the force that controls the motion of our solar system. Identify the variables that affect the strength of gravity. Predict how motion would change if gravity was stronger or weaker. So you're supposed to explore it. I went through the controls. Compare the motion of the Earth moving around the sun with the moon moving around the Earth. If you have your partner and each have a computer, try choosing a different view on each computer for this. Okay, so Earth moves around the sun, so that would be this, right? Okay, and you're supposed to compare that to the moon, like, so you kind of look at all the forces and the path, and then you have the moon and the Earth. So what's the difference? So draw a picture, describe what are some things that are the same, what are some things that are different. For the sun and earth system, draw the path of the earth with gravity on and with gravity off. Why do you think gravity is important? So make sure you're just reading the prompts and playing with the simulation. Why do you think the earth moves but the sun does not move? Good questions. So play with the simulation to find ways to change the length of the blue gravity force arrows. So what happens when you put a star and a planet closer together? Let's see. Why did it say star? I don't think we have stars. So we're trying to make the blue arrows change. What kind of things can we do? We can change mass. Let's see. Blue arrows change. So there's things you can do. You could change their distance. So what happens to the blue arrow if I put it farther away? What if I put it closer? Stuff like that. So check that out. Because the size of the arrow represents the magnitude of the force, right? Like how big is it number wise? Again, here you can draw on these. And that's it. So fill that out to the best of your ability, and I will see what happens. And if you have questions, let me know. What would happen? All right.